Right of pi on 2 in this picture means from here, correct?
Yep.
But in terms of unit circle, what does right of pi on 2 mean? It means greater than pi on 2. So you're really at an angle here, heading backwards this direction towards that vertical pole. Does that make sense?
Sine is positive, cosine is negative.
Oh, here we go. Now we got something going here.
So it'll be negative?
So what? Hold on. Let's say the whole thing out. Just everything you're saying. What quadrant are we in?
Quadrant two.
Second. The whole time this limit is happening, we're in the second quadrant, right? You guys with me in the second quadrant?
Yeah.
And now, what's positive in the second quadrant?
Sine.
Right? Because, right, that whole, you guys know that mnemonic, right? All students take calculus,
Nope.
Yeah.
right? All sine, tan, cos. Which ones are positive? You guys remember that from kindergarten? Okay, good. So, sine here is positive, which forces cosine to be negative, and so therefore you know that this is what? This ratio is always negative the whole time, right? So that's what's telling you it's negative infinity. Okay? Knowing the picture of tan, I guess, is easier though, yeah? Not as much thought. But there are other functions we're going to have in a second. The reciprocal functions, which you may not be as familiar with their graphs, and so this is a good way to think about it. This is the way to think about it. Let's try a similar exercise, which involves a reciprocal trig function. You guys remember what those three are, the reciprocal trig functions? Cosecant, secant, and cotan. You want them in that order in your mind. Cosecant, secant, and cotan, right? Cosecant is the reciprocal of the first one you learned. Secant is the reciprocal of the second one. And cotan is the reciprocal of the third one. Okay, everybody agree with those three definitions? So now the book has for us a cosecant here, number 35. It says the limit of cosecant theta as theta heads towards, 0 from the right. Here's our question. Okay? So how many of you are familiar, how many of you know offhand the pictures, the graphs of cosecant, secant, and cotan? Fantastic. All right. So remember that cosecant is 1 on, what is it? 1 on sine theta heading towards 0 from the right. Okay? If we're heading towards the 0 from the right of 0, in terms of the unit circle, where are we? We're at some very small angular displacement here, and it's heading downwards in a sense. It's heading clockwise towards the initial side of any angle, right? Heading towards the positive x-axis. Right? It's heading down there. Move that up a little bit. So that's theta. There's theta there. Theta is approaching 0 from the right. That's our unit circle understanding of this limit. Okay? So now, we said a second ago the mnemonic is all students take calculus, which is telling us which trig functions are positive in these 4 quadrants. It doesn't just tell you the 3 basic ones, it tells you the reciprocals. Because if sine is positive in the first quadrant, then 1 over that positive thing is still positive. So therefore cosecant is also positive, right? So anywhere sine is positive, the first 2, it must mean cosecant is also positive. Okay? So that means the whole time this limit is proceeding, you're dealing with a positive quantity. Agreed? These are my thoughts. So fine. So it's going to be positive something or other, but positive what? What's that? Infinity. Because the top is stuck at a non-zero already, and the bottom is heading towards 0, right? Sine of 0 is 0. So positive infinity, that is our answer. Okay? So what does that mean for the function cosecant? You must have a vertical asymptote at 0, right? 37. Just want to do one more inverse trig, reciprocal trig function. Cotan. Limit 37 as theta approaches 0 again from the right, so it's somewhat related, of -10 cotan x. What on earth is that -10 doing there? Same pictures in our minds, right? Same unit circle picture. We're approaching 0 from the right, which means you have a small angular displacement right above the 0, heading clockwise down towards the 0, right? What's the definition of cotan, though? 1 over tan. But maybe I don't know so much about tan either, so I'm going to use. Oh, Kami Lee. Just smashed your cousin.
Looks
All
like a
right.
G.
That's not a G. That's how I make my thetas. Leave me alone.
Okay.
All right. So cosine theta over sine theta as theta heads towards 0 from the right. There's our way of thinking about cotan in lieu of knowing its graph. All right. So as theta heads towards 0 from the right, draw that same picture again. Just erased it. Here, heading downwards towards that location, towards 0. Here's theta. We are in the first quadrant, so therefore both cos and sine are positive. This whole trip, this limit is making. What is cos heading towards? What's cos theta heading towards? 1. What's sine heading towards?
0.
So therefore it's some sort of infinity. But they're both positive,
Yeah,
but, go ahead, what do you say? Got a negative on there, right? I got a negative, I got a positive, I got a positive, so that makes it negative altogether, so negative infinity. -10 cotan theta has a vertical asymptote at 0.
Wait, explain why cosine and sine are both positive?
Because the whole time this limit's proceeding, we're just slightly above the 0 marker here, right? Just to the right of 0. I mean, just above it in terms of the unit circle. So therefore, in this quadrant, all trig functions are positive. So for every theta value here that this thing is going to make from this small displacement down to 0, cos will always be positive, it's not always positive.
Oh, okay.
But we have this silly -10 on the front, it's going to change the...
Makes all be negative.
Yeah.
Okay.
That's right. You guys have no infinite limits? Ready to move on? Or do you want us to do what the homework has in store? We'll look at the homework and then go to the next section?
Yeah.
Or just go to the next section?
So how much do we have time
Just
for?
next section.
Yeah. okay.
Next section it is.
Whatever. 2.5. It is not infinite limits. It's limits at infinity. So now it's not that the function is heading towards infinity, it's that the x